Hi, welcome to this introductory course on Microsoft AZ-104 certification. The Microsoft AZ-104 certification, previously known as AZ-103, is for the candidates who wants to become an Azure administrator. Candidates for this exam are Azure administrators who implements, manages, and monitors identity, governance, storage, and virtual networks in a cloud environment. The Azure administrator will provision, size, monitor, and adjust resources as appropriate. Candidates should have a minimum of 6 months of hands-on experience administering Azure. Candidates should have a strong understanding of core Azure services, Azure workloads, security, and governance. Candidates for this exam should have experience in using PowerShell, the command line interface, Azure Portal, and ARM templates. The outline of the exam and skills measured are as follows. The exam measures your ability to accomplish the following technical tasks: manage Azure identities and governance, implement and manage storage, deploy and manage Azure compute resources, configure and manage virtual networking, and monitor and backup Azure resources. Cloud computing provides configurable computing resources and services that can be quickly provisioned with minimal management effort. There are Azure services for almost any business computing need. Do you need an interactive website? A backend for a mobile app? Secure storage for your client data? All of these, and more are available. And these resources are available when you need them, and you're typically only charged for the amount you use. Azure provides several configurations, allowing you to blend or transition between on-premises and a solution hosted completely in the cloud. Cloud computing is the provisioning of services and applications on demand, over the internet. Servers, applications, data, and other resources are provided as a service. You can quickly provision computing resources and use the service with minimal management. You shouldn't think of cloud computing as a data center available through the internet. Cloud computing uses virtualization, commodity hardware, and automated processes to provide a self-service user experience to customers. There are 3 deployment models for cloud computing: public cloud, private cloud, and hybrid cloud. Public clouds are the most common way of deploying cloud computing. Services are offered over the public internet, and are available to anyone who wants to purchase them. The cloud resources, such as servers and storage, are owned and operated by a third-party cloud service provider, and delivered over the internet. Services may be free, or sold on demand, allowing customers to pay only per-usage, for the CPU cycles, storage, or bandwidth they consume. Microsoft Azure is an example of a public cloud. Examples of why you would use public cloud. 1. The on-demand, or subscription model, allows you to pay for the portion of CPU, storage, and other resources that you use, or reserve. 2. No requirement to purchase, manage, and maintain on-premises hardware and application infrastructure. The cloud service provider is held responsible for all management and maintenance of the system. 3. Quickly provision infrastructure resources using a web portal, scripts, or via automation. 4. Store data near your users, or in desired locations, without having to maintain your own data centers. 5. The service provider is responsible for hardware maintenance. A private cloud consists of computing resources, used exclusively by users from one business or organization. It can be physically located at your organization's on-site data center, or it can be hosted by a third-party service provider. The term private cloud should not be considered a rebranding of traditional on-premises data centers. A private cloud uses on-premises infrastructure and services to provide similar benefits of the public cloud. It uses an abstraction platform to provide cloud-like services, such as Kubernetes clusters, or a complete cloud environment like Azure Stack. The organization is responsible for the purchase, configuration, and maintenance of the hardware. Communication between the systems is usually on the network infrastructure that the business owns and maintains. For example, a private internal network, or a dedicated fiber optic connection between buildings. Examples of why you would use private cloud. 1. An existing operating environment that can't be replicated in the public cloud. A large organization may choose to commoditize their computing resources. 2. Business-critical legacy applications that can't easily be physically relocated. 3. Data sovereignty and security. A hybrid cloud is a computing environment that combines a public cloud and a private cloud by allowing data and applications to be shared between them. When computing and processing demand fluctuates, hybrid cloud computing gives businesses the ability to seamlessly scale their on-premises infrastructure up to the public cloud to handle any overflow, without giving third-party data centers access to the entirety of their data. Organizations gain the flexibility and computing power of the public cloud for basic and non-sensitive computing tasks, while keeping business-critical applications and on-premises data safely behind a company firewall. Examples of why you would use hybrid cloud. 1. Business reasons require to use an existing operating environment and hardware. 2. Regulation requires that the data needs to remain at a physical location. 3. Public cloud can't replicate a legacy operating environment. 4. Moving workloads to the cloud over time. Cloud computing resources are delivered using 3 different service models: Infrastructure as a Service, Platform as a Service and Software as a Service. The Infrastructure as a Service provider will supply this range of services to you as a service. So, you do not have to go ahead and create that infrastructure on your premise. Infrastructure as a Service is the most basic category of cloud computing services. With Infrastructure as a Service, you rent the infrastructure servers, virtual machines, storage networks, and operating systems. The user is responsible for installation, configuration, and management of the software inside that operating system. But the cloud provider is responsible for ensuring that the underlying cloud infrastructures, virtual machine, storage, and networking is always available for the user. Platform as a Service. Platform as a Service provides an environment for building, testing, and deploying software applications. Let's understand this. Developers are responsible for building great applications that we have today. They are very good at writing great code and making sure that the application works and performs at its best. But one of the major roadblocks that developers have is, they do not have an understanding of the underlying infrastructure where the application will be hosted. For example, the developer may not know what encryption is and what backups are. The Platform as a Service provides an environment for building such applications so that the developer does not have to worry about those concepts and can focus on writing the best code. For example, when deploying a web application using Platform as a Service, you do not have to install an operating system. You do not have to even take care of the Windows updates or install the antivirus on the machine. Platform as a Service is a complete development and deployment environment in the cloud. The cloud user, or the developer, is responsible for the development of their own applications. However, they are not responsible for managing the server or the underlying infrastructure. The cloud provider is then responsible for operating system management and network and service configuration. Software as a Service is a method of software delivery that allows data to be accessed from any device with an internet connection and a web browser. In this SaaS-based model, software vendors host and maintain the seller's database and the code that constitute the application. First, the companies do not have to invest in extensive hardware to host the software. And this in turn allows buyers to outsource most of the idea responsibilities. A major benefit of SaaS is being able to spread out costs over time. Some of the examples that you can talk about is Office 365, which is a cloud-based email delivery model from Microsoft. The other examples are Salesforce, Facebook, and Gmail, because you do not have to install anything. All you need is a browser and a login with the user and password given by the cloud SaaS provider. The Azure portal is great for performing single tasks and to see a quick overview of the state of your resources. But for tasks that need to be repeated daily or even hourly, using the command line and a set of tested commands or scripts can help get your work done more quickly and avoid errors. The Azure CLI is a command line program to connect to Azure and execute administrative commands on Azure resources. It runs on Linux, Mac OS, and Windows and allows administrators and developers to execute their commands through a terminal or command line prompt instead of a web browser. For example, to restart a virtual machine, you would use a command like the following. The Azure CLI provides cross-platform command line tools for managing Azure resources and can be installed locally on Linux, Mac, or Windows computers. The Azure CLI can also be used from a browser through the Azure Cloud Shell. In both cases, it can be used interactively or scripted. You can install Azure CLI from the link given in the description. The Azure CLI lets you control nearly every aspect of every Azure resource. You can work with resource groups, storage, virtual machines, Azure Active Directory, Azure AD, containers, machine learning, and so on. Commands in the CLI are structured in groups and subgroups. Each group represents a service provided by Azure, and the subgroups divide commands for these services into logical groupings. For example, the storage group contains subgroups including account, blob, storage, and queue. So, how do you find the particular commands you need? One way is to use AZ-find. Example, find the most popular commands related to the word blob. Example, show me the most popular commands for an Azure CLI command group, such as AZVM. If you already know the name of the command you want, the help argument for that command will get you more detailed information on the command, and for a command group, a list of the available subcommands. So, with our storage example, here's how you can get a list of the subgroups and commands for managing blob storage. Azure provides 3 administration tools to choose from: the Azure Portal, the Azure CLI, Azure PowerShell. They all offer approximately the same amount of control. Any task that you can do with one of the tools, you can likely do with the other 2. All 3 are cross-platform, running on Windows, Mac OS, and Linux. They differ in syntax, setup requirements, and whether they support automation. The Azure Portal is a website that lets you create, configure, and alter the resources in your Azure subscription. The portal is a graphical user interface that makes it convenient to locate the resource you need and execute any required changes. The portal does not provide any way to automate repetitive tasks. The Azure CLI is a cross-platform command line program to connect to Azure and execute administrative commands on Azure resources. For example, to create a VM, you would use a command like the following. The Azure CLI is available in 2 ways: inside a browser, via the Azure Cloud Shell, or with a local install on Linux, Mac, or Windows. In both cases, it can be used interactively or scripted. For interactive use, you first launch a shell, such as cmd.exe, on Windows, or bash on Linux, or Mac OS, and then issue the command at the shell prompt. To automate repetitive tasks, you assemble the commands into a shell script, using the script syntax of your chosen shell, and then execute the script. Azure PowerShell is a module that you add to Windows PowerShell, or PowerShell Core, to let you connect to your Azure subscription and manage resources. Azure PowerShell requires PowerShell to function. PowerShell provides services like the shell window, command parsing, and so on. Azure PowerShell adds the Azure-specific commands. For example, Azure PowerShell provides the new AZVM command that creates a virtual machine for you inside your Azure subscription. To use it, you would launch the PowerShell application, and then issue a command like the following. Azure PowerShell is also available in 2 ways: inside a browser via the Azure Cloud Shell, or with a local install on Linux, Mac, or Windows. In both cases, you have 2 modes to choose from. You can use it in interactive mode, in which you manually issue one command at a time, or in scripting mode, where you execute a script that consists of multiple commands. There is approximate parity between the portal, the Azure CLI, and Azure PowerShell, with respect to the Azure objects they can administer, and the configurations they can create. They are also all cross-platform. This means you will typically consider several other factors when making your choice. 1. Automation. Do you need to automate a set of complex or repetitive tasks? Azure PowerShell and the Azure CLI support this while the portal does not. 2. Learning curve. Do you need to complete a task quickly, without learning new commands or syntax? The Azure portal does not require you to learn syntax or memorize commands. In Azure PowerShell and the Azure CLI, you must know the detailed syntax for each command you use. 3. Team skill set. Does your team have existing expertise? For example, your team may have used PowerShell to administer Windows. If so, they will quickly become comfortable using Azure PowerShell. Products and services in Azure are arranged by category, which has various resources that you can provision. You select the Azure products and services that fit your requirements, and your account is billed according to Azure's pay for what you use model. When you provision an Azure resource, Azure creates one or more meter instances for that resource. The meters track the resource's usage, and generate a usage record, that is used to calculate your bill. To make estimates easy for customers to create, Microsoft developed the Azure Pricing Calculator. The Azure Pricing Calculator is a free web-based tool that allows you to input Azure services and modify properties and options of the services. It outputs the costs per service and total cost for the full estimate. Azure Resource Groups. Resource groups are a fundamental element of the Azure platform. A resource group is a logical container for resources deployed on Azure. These resources are anything you create in an Azure subscription, like virtual machines or application gateways. All resources must be in a resource group, and a resource can only be a member of a single resource group. Many resources can be moved between resource groups, with some services having specific limitations or requirements to move. Resource groups can't be nested. By placing resources of similar usage, type, or location, you can provide some order and organization to resources you create in Azure. If you delete a resource group, all resources contained within are also deleted. Resource groups are also a scope for applying role-based access control permissions. Resource groups can be created by using the following methods. When creating a new Azure resource, there are typically 3 steps. 1. Connect to your Azure subscription. 2. Create the resource. 3. Verify that creation was successful. Let's see how to create a resource group using CLI. 1. Connect. Since you're working with the local install of the Azure CLI, you'll need to authenticate before you can execute Azure commands, by using the Azure CLI login command. 2. Create. You'll often need to create a new resource group before you create a new Azure service, so we'll use resource groups as an example to show how to create Azure resources from the CLI. 3. Verify. For many Azure resources, the Azure CLI provides a list subcommand to view resource details. Let's see how to create a resource group using Azure Portal. 1. Open a web browser, and sign into the Azure Portal. 2. On the Azure Portal menu, or from the home page, select Create a Resource. 3. Type Resource Group in the search box, and hit Enter. 4. The first item in the list should be the resource group resource. Select it, and then select the Create button. 5. Enter your resource group name. Select the subscription, and select the region. Then select Review, plus Create, and then Create, to create the resource group. Tags are name-value pairs of text data that you can apply to resources and resource groups. Tags allow you to associate custom details about your resource. A resource can have up to 50 tags. Azure Policy is a service you can use to create, assign, and manage policies. These policies apply and enforce rules that your resources need to follow. These policies can enforce these rules when resources are created, and can be evaluated against existing resources to give visibility into compliance. RBAC provides fine-grained access management for Azure resources, enabling you to grant users the specific rights they need to perform their jobs. RBAC is considered a core service and is included with all subscription levels at no cost. Using RBAC, you can 1. Allow one user to manage VMs in a subscription, and another user to manage virtual networks. 2. Allow a database administrator group to manage SQL databases in a subscription. 3. Allow a user to manage all resources in a resource group, such as VMs, websites, and virtual subnets. 4. Allow an application to access all resources in a resource group. Azure Active Directory. Azure Active Directory, Azure AD, is Microsoft's cloud-based identity and access management service. It simplifies authentication for developers by providing identity as a service. It supports industry-standard protocols. Azure AD allows users to sign in and view resources. And it has features to help secure your identities, such as identity protection and multi-factor authentication. Microsoft services such as Azure and Office 365 use Azure AD to store and manage users. Whenever Office 365 needs to verify a user, for example, Azure AD performs all identity and access management. The employees can sign in and access resources such as external resources, such as Microsoft Office 365, the Azure Portal, and thousands of other SaaS applications. internal resources, such as apps on your corporate network and intranet, along with any cloud apps developed by your own organization. Azure AD is not a cloud version of Windows Server Active Directory. It's also not intended as a complete replacement for an on-premises Active Directory. If you are already using a Windows AD server, you can connect it to Azure AD to extend your directory into Azure. Azure AD can also be used independently of Windows AD. Microsoft offers several cloud-based offerings today, all of which can use Azure AD to identify users and control access. Subscriptions in Azure are both a billing entity and a security boundary. Resources such as virtual machines, websites, and databases are always associated to a single subscription. Each subscription also has a single account owner who is responsible for any charges incurred by resources in that subscription. If your organization wants the subscription to be billed to another account, you can transfer ownership of the subscription. A given subscription is also associated to a single Azure AD directory. Multiple subscriptions can trust the same directory, but a subscription can only trust one directory. Users and groups can be added to multiple subscriptions. This allows the user to create, control, and access resources in the subscription. When you add a user to a subscription, the user must be known to the associated directory as shown in the image. Companies that use an on-premise Windows Server Active Directory solution can integrate their existing users and groups with Azure Active Directory with Azure AD Connect. This is a free tool you can download and install to synchronize your local AD with your Azure directory. With Azure AD Connect, you can provide your users with a common identity for Office 365, Azure, and SaaS applications integrated with Azure AD in a hybrid identity environment. Azure AD Connect provides several components that you can install to create a hybrid identity system. Create an Azure AD tenant. To start, you'll use the Azure portal to create a new Azure AD tenant. 1. Go to the Azure portal. 2. On the Azure portal menu or from the home page, select Create a Resource. 3. Select the identity category, and then select Azure Active Directory. 4. Fill in the Create Directory page with these values, and then select Create. 5. When directory creation is complete, select Click here to manage your new directory. Next, let's create a new registration in the Azure AD tenant for the web application. By registering the application, we mark the app as trusted by the tenant, and specify critical configuration values. 1. On the Azure Active Directory page, under Manage, select App Registrations. 2. In the App Registrations pane, select New Registration. 3. Fill in the Create page with these values, and then select Register. 4. In the next page, note the application ID and directory ID values, and record them for later. You'll need these to complete the configuration file for this project. You've now configured the Azure AD tenant, and performed the initial application registration, to enable your application to communicate with your Azure AD tenant. Keeping your cloud data and resources safe is a shared responsibility between you and Azure. Keeping track of created resources across the organization, and ensuring they comply with your security policies, is a full-time job for security operations. A single misconfigured option can expose customer data, or provide access to internal systems to attackers trying to penetrate your network. Luckily, Azure offers several tools to help identify security issues, secure your services, and harden your exposed network. Azure Security Center is one of the primary tools used to detect threats. Security Center allows organizations to control and monitor the security of all of their running resources, using intelligent threat detection to protect them from cyber attacks. As part of that threat detection, Security Center provides recommendations to close potential security holes and ensure compliance with your corporate policy and security guidelines. Security Center provides an easy-to-read dashboard which shows compliance, security health, and security alerts. This is available right off the main Azure portal dashboard, or through the search window. You can view collected security alerts directly in Azure Security Center on the Overview page, through command line tools, or using the REST API. Selecting the Threat Protection tile presents more detailed information, as shown in the image. Azure Monitor is a service for collecting and analyzing telemetry. It helps you get maximum performance and availability for your cloud applications, and for your on-premises resources and applications. It shows how your applications are performing and identifies any issues with them. The diagram shown gives a high-level view of Azure Monitor. On the left are the sources of monitoring data. At the center of the diagram are the data stores for metrics and logs. On the right are the functions that Azure Monitor performs with this collected data, such as analysis, alerting, and streaming to external systems. Imagine you are a security engineer for a large manufacturing firm. Your company works on several big contracts. Clients send you their confidential designs, which are then stored in your Azure infrastructure. Plenty of hackers would love to get their hands on the next generation designs, and it's your job to protect them. Azure Multi-Factor Authentication supplies added security for your identities, by requiring 2 or more elements for full authentication. These elements fall into 3 categories. 1. Something you know, which might be a password or the answer to a security question. 2. Something you possess, which might be a mobile app that receives a notification or a token-generating device. 3. Something you are, which typically is a biometric property, such as a fingerprint or face scan used on many mobile devices. Using Azure MFA increases identity security by limiting the impact of credential exposure. To fully authenticate, a malicious hacker who has a user's password would also need their phone or their fingerprint. Authentication with only a single factor is insufficient, and without authentication from Azure MFA, a malicious hacker is unable to use those credentials to authenticate. You should enable Azure MFA wherever possible, because it adds enormous benefits to security. Configure multi-factor authentication. 1. Sign into the Azure portal using a global administrator account. 2. Navigate to the Azure Active Directory dashboard using the Azure Active Directory option in the sidebar. 3. Select MFA under the Security group. Here you will find options for multi-factor authentication. 4. Select the additional cloud-based MFA settings link under Configure. A new browser page will open, where you can see all the MFA options for Azure. Set up conditional access rules for MFA. How to set up conditional access policy rules that would enforce MFA for guest users accessing specific apps on your network. 1. Switch back to the Azure portal and select Azure Active Directory greater than conditional access. 2. Select New Policy from the top menu. 3. Name your policy, for example all guests. 4. Select Users and Groups to open the panel. Select Users and Groups. Check the All Guest and External Users checkbox to apply this to all guests. Select Done to close the panel. 5. Select Cloud Apps or Actions. Select Apps and press the Select group. Choose an application where you want to enable Azure MFA such as Visual Studio App Center. Select and then Done to close the panel. 6. Review the Conditions section. Select Locations and then configure it for any location. 7. Under Access Controls select Grant and make sure that Grant Access is selected. Select the Require Multi-Factor Authentication checkbox, this is what enforces MFA. 8. Select to close the window. 9. Set Enable Policy to On. 10. Select Create to create the policy. Teams today must release apps quickly to attract and keep business. This requirement forces software development and support teams to always look at solutions that save time and reduces costs. An ideal solution will reduce the time spent on creating and configuring deployment environments, and simplify the software deployment process. The idea of using software containerization technology as a time-saving and cost reduction solution is popular. One of the strengths of containerization is that you don't have to configure hardware and spend time installing operating systems and software to host a deployment. Containers are isolated from each other, and multiple containers can run on the same hardware. This configuration helps us use hardware more efficiently, and can help improve our application's security. Docker is a set of platform-as-a-service products that uses OS-level virtualization to deliver software in packages called containers. Containers are isolated from one another, and bundle their own software, libraries, and configuration files. They can communicate with each other through well-defined channels. The process of developing and managing applications in a company typically includes one or more teams. There's a development team that creates the software, and an operations team, responsible for the deployment of these applications. The operations team is also responsible for the management of the application hosting infrastructure. Docker is a containerization platform used to develop, ship, and run containers. Docker doesn't use a hypervisor, and you can run Docker on your desktop or laptop if you're developing and testing applications. The desktop version of Docker supports Linux, Windows, and Mac OS. For production systems, Docker is available for server environments, including many variants of Linux and Microsoft Windows Server 2016 and above. Many clouds, including Azure, supports Docker. A container is a loosely isolated environment that allows us to build and run software packages. These software packages include the code and all dependencies to run applications quickly and reliably on any computing environment. We call these packages container images. The container image becomes the unit we use to distribute our applications. Software containerization is an OS virtualization method that is used to deploy and run containers without using a virtual machine. Containers can run on physical hardware, in the cloud, VMs, and across multiple OSs. Let's take a look at Docker architecture. The Docker client. The Docker client is a command line application that provides us with a command line interface to interact with the Docker server. The Docker command uses the Docker REST API to send instructions to either a local or remote server and functions as the primary interface we use to manage our containers. The Docker server. The Docker server is a daemon. The daemon responds to requests from the client via the Docker REST API and can interact with other daemons. The Docker server is also responsible for tracking the lifecycle of our containers. Docker objects. There are several objects that you'll create and configure to support your container deployments. These include networks, storage volumes, plugins, and other service objects. We won't cover all of these objects here, but it's good to keep in mind that these objects are items that we can create and deploy as needed. Suppose you work for a company doing medical research, and you're responsible for managing the on-premises servers. The servers you administer run all the company infrastructure, from web servers to databases. However, the hardware is aging and starting to struggle to keep up with some of the new data analysis applications being deployed to it. You could upgrade all the hardware, but that's not appealing for several reasons. 1. The servers are physically scattered all around, with minimal staff in each location. You'd like to centralize the upgrade to the home office. 2. The company runs custom data analysis software on several versions of Windows and Linux, sometimes set up with odd configurations that aren't entirely understood. You need a way to test the deployments completely and try different configurations to make sure everything is working before the transition. 3. Business is booming, and the company is growing fast. It's likely that the load on the internal servers, particularly the databases, will continue to grow, requiring your company to either buy for the future or come up with a scaling plan to handle the growth. For these reasons, you decide that it's time to explore the cloud to see if it can help solve the load and scale problem. Since you have a bunch of mixed servers and custom software, it makes sense to look at trying to move servers one at a time into Azure using Azure Virtual Machines. Azure VMs are one of several types of on-demand scalable computing resources that Azure offers. With VMs, you have total control over the configuration and can install anything you need to perform the work. You don't need to purchase physical hardware when you need to scale or extend your data center. Azure provides additional services to monitor, secure, and manage updates and patches to the OS. Performing a migration of on-premises servers to Azure requires planning and care. You can move them all at once, or more likely, in small batches or even individually. Before you create a single VM, you should sit down and sketch out your current infrastructure model and see how it might map to the cloud. Let's walk through a checklist of things to think about. Start with the network. Name the VM. Decide the location for the VM. Determine the size of the VM. Understanding the pricing model. Storage for the VM. Select an operating system. The first thing you should think about isn't the virtual machine at all, it's the network. Virtual networks are used in Azure to provide private connectivity between Azure virtual machines and other Azure services. VMs and services that are part of the same virtual network can access one another. By default, services outside the virtual network cannot connect to services within the virtual network. You can, however, configure the network to allow access to the external service, including your on-premises servers. Once you have mapped out your communication and network requirements, You can start thinking about the VMs you want to create. A good plan is to select a server and take an inventory. We can then start to answer some of the questions Azure will have for a new virtual machine. What does the server communicate with? Which ports are open? Which OS is used? How much disk space is in use? What kind of data does this use? Are there restrictions, legal or otherwise, with not having it on premises? What sort of CPU, memory, and disk I/O load does the server have? Is there a burst traffic to account for? You should choose names that are meaningful and consistent, so you can easily identify what the VM does. Just like a physical computer in your data center, VMs have several elements that are needed to do their job. Thus we need to create an Azure resource, which will have the following elements. 1. The VM itself. 2. Storage account for the disks. 3. Virtual network. 4. Network interface to communicate on the network. 5. Network security group to secure the network traffic. 6. Public internet address. The Azure portal provides an easy-to-use, browser-based user interface that allows you to create and manage all your Azure resources. Let's assume you want to create a VM running an Ubuntu server. Setting up a site isn't difficult, but there are a couple of things to keep in mind. You need to install and configure an operating system, configure a website, install a database, and worry about things like firewalls. To create a virtual machine using Azure Portal, you need to perform the following steps. 1. Sign into the Azure Portal. 2. Click on the Create a Resource option in the top left corner of the portal page. The Azure Marketplace pane will open. 3. Use Search the Marketplace search bar to find Ubuntu server. You see a list of options. Select the option that reads Ubuntu Server 18.04 LTS as shown below. 4. The pane that opens next presents licensing information for the image we're about to use. Click Create. Now we need to configure the basic parameters of our Ubuntu virtual machine. If some of the options at this point are unfamiliar to you, that's okay. You'll learn all of these options in the complete AZ-104 course. You're welcome to copy the values used here. 1. Use the following values on the Basics tab. The subscription should be set to Concierge subscription. The resource group should be set to Resource Group Name. Enter the virtual machine name as Test Ubuntu Cust VM. Select a region close to you from the following list. For availability options, choose No Infrastructure Redundancy Required. The image should be the Ubuntu Server 18.04 LTS option we selected from the marketplace. Check to make sure the size of the VM set as standard D2SV3. For the authentication type, switch to password. Enter your username and password. 2. There are several other tabs you can explore to see the settings you can influence during the VM creation. Once you're finished exploring, click Review plus Create to review and validate the settings. 3. On the review screen, Azure will validate your settings. You might need to supply some additional information based on the requirements of the image creator. Verify all the settings are set the way you want, and then click Create to deploy and create the VM. 4. You can monitor the deployment through the Notifications panel. Click the icon in the top toolbar to show or hide the panel. 5. The VM deployment process takes a few minutes to complete. You'll receive a notification informing you that the deployment succeeded. Click on the Go to Resource button to go to the VM overview page. 6. Here you can see all the information and configuration options for your newly created Ubuntu VM. One of the pieces of information is the public IP address. 7. By default, Ubuntu Server 18.04 LTS image doesn't install any reachable public services on the public IP address. However, recall that when you enabled password authentication in an earlier step, the UI also gave an option to enable SSH. SSH allows you to connect to your VM via public IP using any SSH client. The Azure portal is the easiest way to create resources such as VMs when you are getting started. However, it's not necessarily the most efficient or quickest way to work with Azure, particularly if you need to create several resources together. Some other ways to create and administer resources in Azure: Azure Resource Manager, Azure PowerShell, Azure CLI, Azure REST API, Azure Client SDK, Azure VM Extensions. Let's assume you wanted to create a copy of a VM with the same settings. You could create a VM image, upload it to Azure, and reference it as the basis for your new VM. This process is inefficient and time-consuming. Azure provides you with the option to create a template from which to create an exact copy of a VM. Resource Manager templates are JSON files that define the resources you need to deploy for your solution. You can create resource templates from the Settings section for a specific VM by selecting the Export Template option. You have the option to save the resource template for later use, or immediately deploy a new VM based on this template. Creating administration scripts is a powerful way to optimize your workflow. You can automate everyday repetitive tasks, and once a script has been verified, it will run consistently, likely reducing errors. Azure PowerShell is ideal for one-off interactive tasks, and the automation of repeated tasks. For example, you can use AZ-VM to create a new Azure virtual machine. As shown here, you supply various parameters to handle the large number of VM configuration settings available. Most of the parameters have reasonable values, you only need to specify the required parameters. Another option for scripting and command line Azure interaction is the Azure CLI. Like Azure PowerShell, the Azure CLI is a powerful way to streamline your administrative workflow. Unlike Azure PowerShell, the Azure CLI does not need PowerShell to function. For example, you can create an Azure VM with the AZ-VM create command. Generally speaking, both Azure PowerShell and Azure CLI are good options if you have simple scripts to run and want to stick to command line tools. When it comes to more complex scenarios, where the creation and management of VMs form part of a larger application, with complex logic, another approach is needed. You can interact with every type of resource in Azure programmatically. The Azure REST API provides developers with operations, categorized by resource as well as the ability to create and manage VMs. The Azure Compute APIs give you programmatic access to virtual machines and their supporting resources. With this API, you have operations too. Create and manage availability sets. Add and manage virtual machine extensions. Create and manage disks, snapshots, and images. Access the platform images available in Azure. Retrieve usage information of your resources. Create and manage virtual machines. Create and manage virtual machine scale sets. The Azure Client SDK encapsulates the Azure REST API, making it much easier for developers to interact with Azure. The Azure Client SDKs are available for a variety of languages and frameworks, including .NET-based languages such as C#, Java, Node.js, PHP, Python, Ruby, and Go. Here's an example snippet of C# code to create an Azure VM. Here's the same snippet in Java using the Azure Java SDK. Azure VM extensions are small applications that allow you to configure and automate tasks on Azure VMs after initial deployment. Azure VM extensions can be run with the Azure CLI, PowerShell, Azure Resource Manager templates, and the Azure portal. You bundle extensions with a new VM deployment or run them against an existing system. Azure Backup is a backup-as-a-service offering that protects physical or virtual machines no matter where they reside, on-premises or in the cloud. Azure Backup can be used for a wide range of data backup scenarios. Files and folders on Windows OS machines, physical or virtual, local or cloud. Application-aware snapshots. Popular Microsoft Server workloads such as Microsoft SQL Server, Microsoft SharePoint, and Microsoft Exchange. Native support for Azure virtual machines, both Windows and Linux. Linux and Windows 10 client machines. Let's now use the Azure portal to deploy a Linux virtual machine, running Ubuntu 18.04 LTS. To see your VM in action, you also SSH to the VM and install the NGINX web server. First you'll need an SSH key pair. Open a bash shell, and use SSH keygen to create an SSH key pair. If you don't have a bash shell on your local computer, you can use the Azure Cloud Shell. Let's create an SSH key pair. 1. Sign into the Azure portal. 2. In the menu at the top of the page, select the shown icon to open Cloud Shell. 3. Make sure the Cloud Shell says bash in the upper left. If it says PowerShell, Use the drop-down to select Bash and select Confirm to change to the Bash shell. 4. Type the shown text to create the SSH key. 5. You will be prompted to enter a file in which to save the key pair. Just press Enter to save in the default location, listed in brackets. 6. You will be asked to enter a passphrase. You can type a passphrase for your SSH key or press Enter to continue without a passphrase. 7. The SSH keygen command generates public and private keys, with the default name. The command returns the full path to the public key. Use the path to the public key to display its contents with cat by typing the shown text. 8. Copy the output of this command, and save it somewhere to use later in this article. This is your public key, and you will need it when configuring your administrator account, to log into your VM. Let's now create a Linux virtual machine with Azure Portal. 1. Type virtual machines in the search. 2. Under Services, select Virtual Machines. 3. In the Virtual Machines page, select Add. The Create a Virtual Machine page opens. 4. In the Basics tab, under Project Details, make sure the correct subscription is selected and then choose to create new resource group. Type My Resource Group for the name. 5. Under Instance Details, type My VM for the virtual machine name, choose East US for your region, and choose Ubuntu 18.04 LTS for your image. Leave the other defaults. 6. Under Administrator Account, select SSH Public Key, type your username, then paste in your public key. Remove any leading or trailing white space in your public key. 7. Leave the remaining defaults and then select the Review plus Create button at the bottom of the page. 8. On the Create a Virtual Machine page, you can see the details about the VM you are about to create. When you are ready, select Create. Let's now connect to the virtual machine. We'll create an SSH connection with the VM. 1. Select the Connect button on the Overview page for your VM. 2. In the Connect to Virtual Machine page, keep the default options to connect by IP address over port 22. In Login, using VM local account, a connection command is shown. Select the button to copy the command. The following example shows what the SSH connection command looks like. 3. Using the same bash shell you used to create your SSH key pair, paste the SSH connection command into the shell to create an SSH session. To see your VM in action, install the nginx web server. From your SSH session, update your package sources and then install the latest package. Use a web browser of your choice to view the default nginx welcome page. Type the public IP address of the VM as the web address. The public IP address can be found on the VM overview page or as part of the SSH connection string you used earlier. Data comes in different shapes and sizes, and no single storage solution fits all data. Azure provides many ways to store your data. There are multiple database options like Azure SQL Server, Azure Cosmos DB, and Azure Table Storage. Azure offers multiple ways to store and send messages, such as Azure Queues and Event Hubs. You can even store loose files using services like Azure Files and Azure Blobs. The key factors to consider in deciding on the optimal storage solution are how to classify your data, how your data will be used, and how you can get the best performance for your application. Once you've identified the kind of data you're dealing with, structured, semi-structured, or unstructured, the next step is to determine how you'll use the data. Choosing the correct storage solution can lead to better performance, cost savings, and improved manageability. Azure selected 4 of these data services and placed them together under the name Azure Storage. The 4 services are Azure Blobs, Azure Files, Azure Queues, and Azure Tables. The following illustration shows the elements of Azure Storage. Let's take a look at some of the types of data you will need the Azure Cloud Storage for, and see which Azure Storage service is recommended, based on data classification and operations involved with the data. 1. Product Catalog Data. This type of data is semi-structured, because of the need to extend or modify the schema for new products. Customers require a high number of read operations, with the ability to query on many fields within the database. While the business requires a high number of write operations to track the constantly changing inventory. Thus the recommended service for this type of data is Azure Cosmos DB. 2. Photos and Videos. This type of data is unstructured, and only need to be retrieved by ID. Customers require a high number of read operations with low latency. Updates will be somewhat infrequent, and can have higher latency than read operations. Thus the recommended service for this type of data is Azure Blob Storage. 3. Business data. This type of data is structured. It is read-only, and needed for complex analytical queries across multiple databases. Thus the recommended service for this type of data is Azure SQL Database. A storage account is a container that groups a set of Azure Storage services together. Only data services from Azure Storage can be included in a storage account. Combining data services into a storage account lets you manage them as a group. The settings you specify when you create the account, or any that you change after creation, are applied to everything in the account. Deleting the storage account deletes all of the data stored inside it. A storage account is an Azure resource, and is included in a resource group. The following illustration shows an Azure subscription containing multiple resource groups, where each group contains one or more storage accounts. A storage account defines a policy that applies to all the storage services in the account. For example, you could specify that all the contained services will be stored in the Western Europe data center, accessible only over HTTPS, and billed to the marketing department's subscription. The settings that are controlled by a storage account are: subscription, location, performance, replication, access tier, secure transfer required, virtual networks. Let's now create a storage account using Azure Portal. 1. Sign into the Azure Portal. 2. On the Azure Portal menu or from the home page, select Create a Resource. 3. In the selection panel that appears, select Storage. 4. On the right side of that pane, select Storage Account. Let's now configure the basic options. First, select a region. Under Project Details, select the Concierge subscription from the subscription drop-down list. Then, select the existing resource group from the drop-down list. Under Instance Details. 1. Enter a storage account name. The name will be used to generate the public URL, used to access the data in the account. 2. Select a location near to you, from the list above. 3. Select Standard for the performance option. This decides the type of disk storage used to hold the data in the storage account. Standard uses traditional hard disks, and Premium uses solid-state drives, SSD, for faster access. 4. Select Storage v2 for the account kind. This provides access to the latest features and pricing. In particular, blob storage accounts have more options available with this account type. 5. Select Locally Redundant Storage for the replication option. Data in Azure Storage accounts are always replicated to ensure availability. This option lets you choose how far away the replication occurs to match your durability requirements. 6. Set the access tier. The hot access tier is ideal for frequently accessed data, and the cool access tier is better for infrequently accessed data. Next, we will configure the networking options. 1. Click the Next. 2. Set the connectivity method option. This option allows you to isolate the storage account on an Azure virtual network. Next, we will configure the advanced options. 1. Click the Next. 2. Set Secure Transfer Required to Enabled. The Secure Transfer Required setting controls whether HTTP can be used for the REST APIs used to access data in the storage account. Setting this option to Enabled will force all clients to use SSL. 3. Leave the Large File Shares option set to Disabled. 4. Leave the Blob Soft Delete option set to Disabled. Soft Delete lets you recover your blob data, in many cases, where blobs or blob snapshots are deleted accidentally or overwritten. 5. Leave the Data Lake Storage Gen 2 option as disabled. This is for big data applications that aren't relevant to this module. Now click Review plus Create to review the settings. This will do a quick validation of your options, to make sure all the required fields are selected. If there are issues, they'll be reported here. Once you've reviewed the settings, click Create to provision the storage account. It will take a few minutes to deploy the account. To verify, first select the Storage Accounts link in the left sidebar. Then, locate the new storage account in the list, to verify that creation succeeded. Subscribe to our channel. and hit the bell icon to never miss a video from us.